Hello friends, very good morning. Myself Dr. M.H. Annaya, and in this video we are going to work out a very good problem on the chapter power screw. Friends, let's see what the question we have for today's video. The question reads like this: the screw rod of a screw press is to take an axial load of 30 kilonewton. The load is given to us. The coefficient of friction for the thread and that of the collar is also given. We are required to determine the specification of the thread, the number of threads and length of nut, and the torque required to raise the load. So these are the things that are asked in the question. So let us start from one by one. So friends, you have this screw rod which is subjected to compressive load, and hence we have the compressive stress induced in the rod, and that is given by sigma c. Compressive stress is W by AC, where W is the load the member has to withstand, that is W is equal to 30 kilonewton, which is equal to 30 into 10 power 3 Newton. And AC is the core area, that's the minimum area of cross section, that is core area. And sigma C is the compressive stress induced in the screw rod. So friends, in this expression, the load is given to us by selecting some suitable material of this screw rod. You will be able to find out what is AC. And once you know the value of AC, you can find out the dimensions of the screw rod, namely the outside dia or the nominal dia D, inside dia or core dia D1, and the pitch of the threads. Now friends, to find out the value of sigma C, let us take C40 as the material of rod, for which the value of sigma u, the ultimate stress, is 569 Newton per mm square, and this is obtained from the machine design data handbook. Friends, let us have a factor of safety not specified in the question equal to 3. And friends, from these two values, you can arrive at sigma c. The compressive stress is sigma u by factor of safety we will take by 3, that is 3 ones are 3, 3 8s are 24, 2, 3 9s are 27, say 0.1 Newton per mm square. Friends, when you have this sigma c, you will substitute the values here and find out what is the core area we get. So here friends, from this we can say the value of this load is equal to 30 into 10 to the power of 3. Core area we got, and the sigma c value, sigma c is equal to sigma c. Therefore, AC, the core area, is equal to 30 into 10 to the power of 3 divided by the sigma c value, which you took it as 569 by 3. And friends, this works out to 158.17, 158.17 millimeter square. This is the core area of the screw rod. Friends, once you have this core area, there is a table in the machine design data handbook on square threads, and we use here square threads of normal series, and corresponding to this value we don't have the normal series. There is a core area next to this, that is given by 227 mm square area, that is the area corresponding to which we are going to have the outside diameter D is equal to 27 mm, the inside dia, that is D1, is equal to 22 mm, and the pitch of this is difference of these two, that is 5 millimeter. These are the dimensions of the screw rod. That is to say, the screw rod we select should have a nominal dia 27 mm, core dia 22 mm, which is equal to 5 millimeter. This is how we specify the square thread. So we have completed the first part of the question, that is part A. Next is asking us to find out the number of threads and length of nut. So friends, corresponding to this screw rod, you have a nut through under which this passes through, and we will see what is the length of number of threads required. Friends, in part B, the number of threads required in the threads in nut is given by I. And we have got an expression in the data handbook given by I is equal to 4W divided by sigma B dash by D square minus D1 square. Friends, this equation is available in the machine design handbook. So let us substitute the values here. It is 4 times, W is 30 kilonewton, 30 into 10 to the power of 3. And friends, sigma B dash. In one of previous videos I told you, generally the value of this bearing pressure for the cast iron and also for the bronze lies between 12 to 17. So generally for the combination of steel rod, that is a screw, and the nut made of cast iron or bronze, we can take this value equal to 15 MPa multiplied by pi bracket outside diameter square 27 square minus 22 square. Friends, if you simplify, you get this answer I as 14 millimeters. This is 22 and 17. I'm sorry, this is 22 and 17 should be. So friends, with the simplification you get I is equal to some 13.98. Say I is equal to 14 threads. That is, to take up this load of 30 kilonewton, the number of threads in the nut should be 14. And friends, next comes calculation of what is called the length of nut required, because there should be sufficient pressure, bearing pressure. So on the bearing area, we have length of nut is represented by L suffix n, and that Ln is given by the formula I into pitch. This again available in the machine design handbook. I is equal to 14, pitch is equal to 5. So friends, you get 70 mm as the length of the nut required to sustain or to take up this load. Friends, we have completed the second part, and finally we are left with the calculation of the torque required to raise the load. So we have to find out what is the torque. And friend, the torque is given by the formula Mt is equal to W d2 by 2 tan alpha plus mu divided by 1 minus mu tan alpha plus mu c bc by 2. This expression is again available in the machine design handbook MDH. Friends, let's see what these values are. The value of W is the load, that is 30 into 10 to the power of 3 Newton, and D2 is the mean diameter of the screw rod. It is outside dia plus inside dia by 2. That is D plus D1 by 2. Outside dia is equal to 22. Inside dia 17 by 2. So this is 39 by 2 come to 19.5 mm is the mean dia. That's the value of D2. Next, tan alpha. We will calculate directly. Tan alpha is equal to L over pi D2. So friend, L stands for the lead. What is lead, friends? If you have a screw rod and a nut accommodated on the rod, when you give one rotation to the nut holding it stationary, the distance covered by the nut along the length of the screw rod for one rotation is called the lead. Here, nothing is specified about whether it is a single start thread or double start thread. So we'll assume this to be double start thread. Generally, we need to raise or lower the load at a faster rate, and hence you can have lead is equal to twice pitch, 2 times pitch. Pitch is 5, 5 into D2 is 19.5. Friends, you will be able to calculate what is this value of tan alpha. Then mu. Friends, mu stands for the coefficient of friction between the screw rod and the nut. So here, if you refer to the machine design data handbook, if you assume the lubricant that is used there as the some high grade oil, heavy lubricant to say, you will have this value of mu. And here in this problem, they have given us the value straight. Thread friction is 0.14. So this is given as 0.14. We know all this. Then mu c, coefficient of collar friction. There is again table in the data handbook, but the value is given as 0.1 collar friction. So then comes DC. Friends, DC stands for the diameter of the collar of the nut. So here, unless otherwise specified, we can approximate the value of DC as 1.5 times the nominal diameter of the screw rod. So we can take DC equal to 1.5 times D, that is 1.5 into D value is 22, that is 33 mm. Friends, after substituting all these values in the equation of torque, friends, we get the value of this torque as torque MT is equal to 11,5067 Newton per millimeter. Friends, next we have got one more part to be added, that is dimensions of handle. Dimensions of handle means the lever used to operate the jaw, and it has got a dimension LH, DH. D stands for dia, L for the length. Friend, if you have this top view of this screw rod, if you take the lever, this lever is of circular cross section, say having diameter DH, and the length of this is LH. So we need to find out what should be the length of the handle required so as one should be able to operate the screw jaw. Friends, here we have got this rod, when it is rotated, it is subjected to bending, and hence we have the bending stress induced in the rod. And now before that we want to find out LH, we will say the torque MT is equal to F into LH. Remember, this is the effort F an average man can apply. That is generally 250 to 300 Newton. So we take it as some 250 Newton. LH is to be found out, and MT value we have calculated as 11,5067 Newton millimeter. Friends, if we calculate the value of this LH works out to 385 millimeter. 385 millimeter is the length of this handle. Then Finally, let's see how to find out the diameter of the handle, that is DH. Friends, while applying pressure or the load here, this rod is subjected to bending. So we hold the end of the lever with both the hands like this and apply load perpendicular to the plane of the board. Say this is the value of this F applied. So friends, because of the load F, the rod is subjected to bending or the hand lever is subjected to bending, and hence there is bending stress induced in the member. So you will say handle or lever is subjected to bending, and hence the bending stress is sigma b is given by the basic formula mb by zb. If it is a torsion load, mt by zt. Friends, mb is given by the load into LH, F into LH. Along with this LH, we have to add some extra length, say around 250 millimeter, for holding the rod and to apply load. So I will say this is F into whatever the LH we have got, that is 385, plus say some 200 extra for holding the rod, divided by ZB. For a circular section, ZB is I by C. I is equal to pi d to the power of 4 by 64. C is equal to d by 2. And as an engineer, you should remember this as pi d 2 by 32. It is the diameter of the handle. I have represented it as this dh. What is the bending stress, friends? So we know the value. We will assume both the screw rod and the lever made of the same material, for which the sigma b will be sigma u by factor of safety, that is 569 by 3, that is equal to the value f is 250 bracket 585 divided by multiplied by 32 and divided by pi dh. Friends, you will be able to solve for dh, that is the diameter of the handle, as 22 mm. So friends, we are able to design the handle, that is we found out what is the length of the handle required and what is the diameter of the handle required. Friends, this is one of the important questions on design of screw jaw, which covers almost the complete concept involved in the power screw. Friends, I hope the presentation was interesting. If you find this to be useful for students doing their engineering program, and it is of some importance to all the channel viewers, please share this information with all your friends. Thank you, friends, for watching my YouTube video. Have a blessed day.